Hey, Oliver.
Hey, Dawson, what are you doing? This is a math lesson, not a cat filming lesson. Oliver, you're not helping.
Oh, sorry.
Hi, class. You know, Dawson's really unpaid help at this point, and you know, we have a lot of help out here, especially with animals. Hello, Oliver. Oh, good. Oh, good. He's going to help out in the lesson. So, as I mentioned this morning to my class, Green Forum, that you're going to do 2 more lessons today, and they're really closely related, so it's pretty easy. So I want you to do 12.3 and 12.4 Tuesday, and it's just taking the opposite operation. So Monday was about addition of fractions with like denominators, and these 2 lessons are about subtracting. So it's pretty basic. You're going to use the model. Again, I provided that for you. You can print that off and use it if you need to. Or you could just go and print off you can use some paper strips. This is kind of what I did. I kind of prepped a little bit. So the big idea behind today's lesson is taking away on a fraction strip or taking away the algorithm of what does that look like. So I'm going to give you a real quick example. So I'm going to draw one of my favorite fraction bars. This is pretty easy, which is going to be the 1/8. So I'm going to cut it in half, half again, till I get 8. So it's really divided by 2. So each one of these equals 1/8. You get the idea, or infinity. That looks kind of like infinity. Do these sideways. Okay, I'm going to provide an example problem for you. So I'm showing you the model, and then also going ahead and show you what it looks like with an algorithm. So let's say we're dealing with 7/8 subtract 5/8. Let's have some proof here. And we want to know what the answer is. So the answer, the directions will say simplify when possible. And that's always what I'll remind you too. So if we said 7/8, so remember when we are doing an addition of fractions, if we just add them all up. So I'm going to use this purple marker. And I'm going to count it out. There's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. And you guys know that 7/8 is almost one whole. 8/8 would be one whole. So when we have our first number represented, and I wanted you to note a couple of things. The denominator is 8 in both, so that makes it really easy. There's another algorithm you have to use if they're unlike denominators, but this is how the 4th grade book starts. Nice, easy way to do it. So let's take a look about 7/8. What does that look like? Subtract 5/8. So I'm going to use a different color. I don't know if blue is good enough, but I'll just use black again. So when we subtract, drawing, so you can use your graph paper at this point, and just make it simple. Keep 1 box per. So even if it's showing 10/12ths, have 10 little boxes out of 12 filled in for your graph, and then just subtract from there. So subtraction happens like this. You start with 5/8 and you go, okay, count down. 1, you need to put a big X over it. 2, 3, 4, 5. And you're left with this amount right here. So what would that be? Right, 2/8. So the simple algorithm, when you rewrite it, looks like this. 7 subtract 5 over 8, because they're the same denominators. That's pretty easy. 7 subtract 5, 2, 8. Uh-oh. What's going on, Oliver?
He's having a little moment. He saw the hummingbird.
Oh, he hears hummingbirds. He doesn't get excited. So when you're looking at 2/8, can I leave it that way? You're right. It needs to be simplified. How do you know that? That's right, 2 is a factor of 8. So an easy way to do that, I didn't give myself a lot of room here, is to divide top and bottom by 2. Because 2 is a factor of 2, and 8 is a factor of 2. So to simplify, you just divide both top and bottom by the same amounts. Hey, film boy, I'm here. And you are left with what? 2 divided by 2? 1. 8 divided by 2? 4. Excellent. So 1/4 is your answer to this whole problem. So it'd be over here if we were to write that again. So to simplify that, 1/4 is the answer. And you go, what? How'd that happen? So I'll show you what that looks like on a fraction model. I'll actually show you the paper, as I did it on paper as well. So as I showed you before, I just took some regular paper and I folded it into 8. So in half, half again, half again. I created all these 8 little windows. Then I labeled them 1/8. Okay. So 5/8, as we showed before, means 5 of these guys. Oh, excuse me, not 5. We did 7. So I'm just going to quickly 1, 2, 3, 4, 5, 6, 7. Not good for expo markers. So now I have 7/8. And you could do, what does that look like? You could say, okay, subtract 5/8. So here you go. 1, 2, 3. I'll count this way. 1, 2, 3, 4, 5. Okay. That kind of leaves you with 2/8 remaining. And if I wanted to show you how to make equivalent fractions, if you look at it, if you line them right up, it equals 4/8. So underneath here, you could do another bar to show how, I'll show you how to simplify using models. So I'll draw my bar down here. Since we're dealing with fourths, it's really easy because 4 is a factor of 8. I'm going to divide this into fourths. Okay, so I've got 1/4, 1/4, 1/4, and 1/4. We said we got rid of 5 of these, so we've got 1, 2, 3, 4, 5. Oh, kitty.
Decided to settle down right there.
Oh, didn't he? And you're left with 1/4. So pretty easy algorithm. It's just subtraction. It's unlike denominators. No, nothing hard. You can cut out those strips if you need to, or just make your own or use graph paper. All right. Don't forget the crossing out. That's a physical help to you. And then the next lesson is just practicing the algorithm a little bit more. Don't forget to simplify. Bye, class. Say goodbye, Oliver.
Oliver, let's get an up-close shot.
Goodness gracious.